So we read that Jada earns $7 per hour mowing her neighbor's lawns. So the two quantities that we're looking at here are $7 and number of lawns, how many lawns she mows. So the two quantities in this situation have a functional relationship, meaning how much money she makes depends on how many lawns she mows. So money is a function of how many lawns. So if we want to write an equation to represent that, we think about inputs and outputs and x values and y values. So the input for this function would be how many lawns she mows. So that is going to be our variable, and it's $7 per lawn. So we have $7 per lawn. I'll make that capital so you can see 7 times the number of lawns is going to tell us how many dollars she makes. If we want to make a graph of this, we want to remember that the input is our independent variable. So that is the number of lawns, which will go down here. And then our output will be the dollars that she earns. And if we want to label these points, for every 1 lawn she mows, she earns $7. So if we put a 1 here, and the point on our graph, we go straight up, the point is right there. So when we go straight over, this is where our 7 would go. So for every 1 lawn, she makes $7. The second question, we're looking at the same thing. We want to talk about inputs and outputs. And if you remember the function machine, if we have sort of the process in here, what we input is the feet, and we convert that into yards by multiplying feet times 1/3. So our equation for this one, our output is yards, so yards is going to equal 1/3 times the feet. We'll do the same thing. We have our independent and our dependent variable. The independent variable is what goes into the function box, so feet is going to go down here on the x-axis, and yards is going to go over here on our y-axis.